Hello, I'd like to explain to you how we're going to make the standard solutions for experiment 5. We're going to make 4 different concentrations of sodium chloride solutions, and then we will weigh 10 milliliters of each so we can calculate the density. The first solution will be made by weighing approximately 15 grams of sodium chloride in a beaker. So you need to record the precise mass. Here I've made up a number, 15.5555 grams of sodium chloride. When we make that solution, all of that goes into flask A. And then we fill flask A to a volume of 100 milliliters. Okay, and that's technically 100.00 milliliters. So we can calculate the molarity of solution A. The molarity of solution A is going to equal the moles of sodium chloride divided by the volume in liters. And if we take 100 milliliters, we can convert that to liters using our metric prefixes. And we find out that's 0.10000 liters. Well, how do we find moles of sodium chloride? We're going to take the mass of sodium chloride and convert it to moles of sodium chloride using the molar mass of sodium chloride. And that's how you get moles of sodium chloride. You divide by the volume in liters, and you'll have the molarity of solution A. Now, solution A was used to make solutions B, C, and D. And we did this using a technique called dilution. So the table up here explains what size of flask we used and how much of solution A we added to each flask. So calculating the molarities for solutions B, C, and D, we're going to use the dilution equation. The molarity of one solution times its volume equals the molarity of the second solution times its volume. So these are all going to be based on diluting solution A. So here where it's saying add this much, that is the volume that is the volume of solution A that is being used. Now this one we've already calculated, so we don't need to look at that one anymore. And when we look at the volume of the new solution, that's going to be the same as the volume of the flask that we made the solution in. So this is, I didn't need to do that. This is the volume of B in milliliters. This is the volume of C in milliliters. And this is the volume of D in milliliters. So when we make solution B, we're going to take 25 milliliters of solution A. 25 milliliters of solution A is going to go into flask B, and we add water until the volume is at the line, which gives us 50.00 milliliters. So to calculate the molarity there, we can use the A and B instead of 1s and 2s. The molarity of solution B times the volume of solution B is going to equal the molarity of solution A times the volume of solution A. We need to rearrange this equation to solve for molarity of B. We do that like this. Those cancel out. And now we have the molarity of B is equal to the molarity of A times the volume we used divided by the volume of B. Making solution C, we take some of solution A and put it into another flask. The volume this time is 5 milliliters. So volume of A is 5 milliliters. The volume of C is 25 milliliters. Molarity of A is still the same. And to make solution D, we pipette 2 milliliters into a 25 ml flask. And so here's our volume of solution D. The volume of solution A that we used was 2 milliliters, and that's really 2.00 milliliters for sig figs purposes, 2.00. And so we can use the volume of D, the volume of A, the molarity of A, and do a calculation much like this. And that's how you will calculate the concentrations for solutions B, C, and D.